Welcome back. Previously, we explored binary logit, which has just two choices. Today, we're going to scale this up to multinomial logit, which can handle any number of choices. And this is important because in the real world, choices are rarely binary. For example, a rideshare platform like Uber or Lyft, they might want to consider many different options in riding, whether that's the size of the vehicle or how quickly it can get you there, or whether it's pooling with other riders. And so we need to be able to come up with a way to tractably handle these many different options. And the multinomial logit is going to extend the elegance of the binary logit, but allow us to apply it to much richer choice settings. But the key is that it will still maintain the same mathematical beauty that the binary case had. So if we have more choices, but we still have the same assumption that the errors are IID type 1 extreme value, then this is going to give us what's called the multinomial logit model. We have the same exact utility specification, but we just have many more options. So instead of two options and one set of differenced utilities, we're going to have capital J options, and that will give us capital J minus 1 differenced utilities that we can estimate the parameters of. So here we still see the same things in our data. We see X, and we see all the different Z's, and then we see the choice that was made. And here, the choice probabilities are going to be very similar, but we're just going to have a summation of exponentiated difference utilities in the denominator. So for any j, we're going to have the exponentiated difference utilities, and then in the denominator of every choice probability, we're going to have the summation of the exponentiated difference choice probabilities. And then for our normalized option, which in this case is capital J, we're going to have a 1 in the numerator and then the same denominator. So now the log likelihood function expands just a little bit. We're going to have this same subtracting off the log of the denominator that we had in the binary case. And then the only difference is that now we have a summation of dij equal 1 times the corresponding difference utility that we had before. So before, this was just, we didn't have the summation, and then we had a 2 instead of a j. But now, because we have j different options, we're going to need to have j minus 1 of these terms. And then the log of the denominator is going to be different as well in the same way. Then we can rearrange this a little bit. We could, and if you don't like this dense notation here, we can make it a much simpler notation with just a summation from j equal 1 to j, and then we have the same d times log of p structure that we had in the binary case. So that is how we generalize from two options to capital J options. And one thing that's really laudable about this formulation is that it's quite elegant and simplified, despite being a very powerful way to model people's preferences given the choices that they've made. And this multinomial logit model is used in nearly any domain of economics or social sciences or business more generally. Transportation planners might use this to forecast how commuters will respond or what ridership will be on a new transportation line. In that case, they might want to consider substitution among different alternatives. So maybe if someone who used to ride the bike, they might take the new transit line. Maybe people who used to drive will take the new transit line, and we want to be able to credibly predict what these substitution patterns will be, because it matters a lot for the final analysis of should we even build this line in the first place. Similarly, market researchers use multinomial logit quite a bit to analyze how similar products will be substituted into and out of as the price changes or as new products come out. Urban economists use the multinomial logit model to estimate neighborhood choice or choice of city to live in. I've published papers using the multinomial logit model to analyze city-to-city migration in the United States. So the bottom line is that this is a powerful tool that can be quite useful in predicting what will happen if the choice setting changes. And that's the type of thing we would need a model for when we're thinking about counterfactual simulations. However, the power and the elegance of this model are not to be overstated, but they're also not to be understated. The problem is that there are some drawbacks to having this level of simplicity that places restrictions on the type of substitution patterns that are even possible within the model. And that can have some severe limitations, and that's what we'll talk about in the next video.